All right, class. Here we are going to talk about the Pythagorean theorem. The Pythagorean theorem only applies to a triangle that has a 90-degree angle in it. We call this a right triangle. A right triangle has two legs and a hypotenuse. Now, to explain how the Pythagorean theorem works, I need to label this leg 1. And here's leg 2. Now, when I show you the equation and I use it, I'm going to call the hypotenuse h. Leg 1 I'm just going to call L1, and leg 2 I'm going to call L2. Now we're going to start by multiplying the length of leg 1 by itself. So we're going to have leg 1 times leg 1. And since I'm using L1 to represent leg 1, I'll write this as L1 times L1. Or I could just call it L1 squared. L1 times L1 is the same as L1 squared. Now the Pythagorean theorem says that once you multiply leg 1 by itself, add leg 2 times itself to that. So here we have leg 1 times leg 1. We're going to add leg 2 times leg 2, which I'm going to rewrite as L2 times L2. And now I can write that as L2 squared. Alright, I ran out of space, so I had to kind of rewrite this. So all of this equals the hypotenuse times itself. So here in this part, I've just put h times h. And so all of this equals a squared. So the Pythagorean theorem says that one leg multiplied itself plus the other leg multiplied by itself equals the hypotenuse multiplied by itself. This is the Pythagorean theorem. Alright, so let's do a problem. Let's say you're given this situation where you're asked to figure out what is the hypotenuse of this right triangle. Make sure I'm clear about that. So from our rule, we know that one of the legs squared plus one of the other legs squared equals the hypotenuse squared. So I know both legs. So for this leg, I'm going to consider this 3 squared. For this leg, I'm going to consider this 3 squared. And since in my problem I called this a question mark, I'm just going to say, hey, my question mark squared by itself. So I want to know what the question mark is. Well, I can do the math. I know 3 times 3 is 9. Same thing over here. And I know 9 plus 9 is 18. So now I know that the question mark multiplied by itself is 18, but that still doesn't tell me what the question mark is. In order to get the question mark by itself, I have to take the square root to get rid of that 2. But if I do that here, I have to do it here. So my question mark becomes the square root of 18. Now if you were to recognize that inside that the 18 is 3 times 3 times 2, you could take a 3 outside of the square root. So as it turns out, the question mark is 3 times the square root of 2. And there's a lesson to be learned here. Notice, both legs are the same length. So whenever you have that situation, if they're the same length, if you want to know the hypotenuse, all you have to do is multiply by the square root of 2. Now let's say you're faced with a situation like this where you know the hypotenuse and you know one of the legs, but you don't know the other. So I'm just going to start by what I know. I know that this multiplied by itself plus this multiplied by itself equals this. So I'm just going to write this squared. So the question mark squared plus 4 squared, which turns out to be 16 because 4 times 4 is 16. All of that has to equal 5 times itself, which becomes 25. Now here, because I need to know what the question mark is, I have to observe that I know the question mark is here, but this 16, I don't want the 16 on this side of the equation because I need everything to go away except the question mark. So I'm going to minus 16 from this side of the equation, but if I do that, I also have to do it here. So here I have minus 16 from both sides. These 16s go away. And over here, 25 minus 16 is 9. Now, I have the question mark in parentheses, but I really don't need to write those. Alright, so again, I have the question mark multiplied by itself equaling 9. So I need to, in order to get the question mark by itself, because it's squared, I have to square root both sides. And that makes the question mark come out by itself. And so the square root of 9 is the same as the square root of 3 times 3. And I haven't really said this before, but I should. When the two 3's come out of the square root, really there's a 1 left inside. And the square root of 1 is just 1. And ultimately the question mark ends up being 3. And from the get-go, if you knew your triangle, your 3, 4, 5 triangle, you would have known that from the start. But just going through the math, this does show that this leg equals 3. All right, and finally, let's say you're given a situation where you do not know this length, but you are given the information of this leg and the hypotenuse. Just for the heck of it, I've been calling this question mark. We can call this whatever we want. So in this one, I'm going to call it Z. So following our rules, we should know that this times itself, which is 6 squared, plus this leg times itself, which I'm deciding to call Z in this case, Z squared, has to equal the hypotenuse multiplied by itself. Now I know that 6 times 6 is 36, and I would expect you to know that. 14 times 14, maybe I wouldn't make you do that kind of head work. It's a little much even for me. But still, let's figure out what Z is. And now I'm going to subtract 36 from both sides, because here I need the 36 to go away in order to get Z all by itself. Now, on this side of the equation, I have a 14 squared minus a 36. Again, I haven't done this multiplication, and over here, I wouldn't probably allow a calculator on a quiz. I would expect you to just leave that as it is. And you can still solve for Z. Here, we're going to take the square root in order to get Z all by itself. So I have to do the square root on this side. And here, I have what I would call a little bit of a strange answer. But this would be an acceptable answer on any quiz or questions that I give you in class. 14 squared is a bit much, so you leave it like this, and you get 100% credit. Okay, folks, that is your lesson on how to do the Pythagorean theorem with actual problems. Have fun with this.